Okay, our next type of tissue, well, we're still on, excuse me, my previous video, I did a series of fibrous connective tissues. So now we're moving into a few different, a little bit more diverse type of connective tissues. So this video will focus on bones, cartilage, and blood. Okay, so starting off with bones. Bone is the hardest connective tissue in the body. It is not the hardest substance in the body. We'll get to that when we talk about teeth, but hardest connective tissue in the body. You guys all know what bones are. You've seen them. Maybe some of you have broken a bone or you know, uh, studied a little bit of the skeleton in the past, or maybe a health class or something. So the really hard part of bone is really learning the connections and the processes and things that are part of it, and then the actual cells that make it up. So we're going to give you a kind of a brief introduction to bone in this unit. Then when we get to the skeletal system, we'll really take a deep dive into what the heck all these things are. So first of all, a bone cell is called an osteocyte. Okay. And again, anytime you see cyte, C-Y-T-E, that's a cell. All right. So osteocytes, and they are within this matrix. Remember, we keep talking about this extracellular matrix within of connective tissue. The matrix is made of collagen and mineral salts. These mineral salts is what makes bone really hard. So remember that the extracellular matrix gives a connective tissue its characteristics and its density, or so that here's where we have this really hard connective tissue. What's the job of bone? Well, you can see it there, and you guys have already talked about these in class. Attachment for muscle. We can store minerals there. Okay, you'll see malnourished individuals sometimes have really weak bones because their bodies have had to take minerals from their bones to nourish them, and then obviously support and protection. Where would it provide protection? Well, think of the skull. The cranium was protecting our brain. The thoracic cage is protecting our lungs. The pelvis is protecting our reproductive organs. Now, when we talk about the things that make up a bone, one of the big things we're going to talk about is this thing called an osteon. Again, this is one of those things where we're just introducing very fast in this unit. So don't get too concerned with the details of this right now. I'm just introducing it. So anyway, a hot osteon, the structural unit of a bone. Okay. So I'm going to show you a picture here in a minute, but these osteons are basically these big circular things that run the length of the bone. And then the osteocytes are within the osteons. Okay. The osteocytes are within these things, these spaces called lacunae. Lacunae right here, Lacunae. Think of like a little cave for something to live in. And you're going to see this with a couple of our tissues. But anyway, the osteocytes are within these little spaces, and then these little spaces are within these patterns called lamella or lamellae, okay, which is right here. It's going to get confusing. These lamella are connected by basically little canals. Think of C-A-N-A-L, canal to start that word. These canals allow blood to travel to each osteocyte, okay? That's confusing. I'm going to show you a picture here in a moment. Now, remember we said before that a blast is a building cell. Well, an osteoblast is a bone building or bone forming cell. When these osteoblasts form a bunch of bone material around themselves, they become inactive. Basically, they've surrounded themselves, and I like to say they painted themselves into a corner. If you've ever heard that expression, think if you're painting a room and you're standing in a corner and you're in the back corner on the very far away from the door, you're surrounding yourself with paint and you can't get out. An osteoblast does that. It secretes a bunch of bone material, that extracellular matrix, and then it basically inactivates itself because it's surrounded itself by all of that hard bone material. An osteoclast is a bone destroying cell. Now, why in the world would we want a bone destroying cell? Well, a couple of reasons. Number one, The formation of bone has to deal with building up and tearing down a bone as you're growing. In addition to that, think about like if you break a bone, right? If you break a bone, there are damaged parts of that bone that we need to repair, possibly remove. An osteoclast is going to come in and do that for us. And there you see it says it's formed by the activity of both osteoblasts and osteoclasts. So now, what was all that stuff I was talking about before? I'm going to try to do this here. This right here, this big circle is an osteon. All right. Now this is an actual picture. This is a bone. All these are osteons. Oops, sorry. All these things are osteons that make up a bone. So this is a one osteon. In the middle of the osteon, I have a blood vessel that goes right down the middle of it. Okay, so all these osteons are making up a bone. They're focusing on one osteon down here at the bottom. Now, within this osteon, I have a couple of things. First of all, I have an osteocyte, okay? And that osteocyte is within a lacuna or lacunae. So here you see it says a lacunae, which contains osteocytes, all right? All these concentric circles that kind of almost look like tree rings, those are lamella. Lamella is the hard bone extracellular matrix, all right? Hard bone extracellular matrix. And that lamella is what makes our bones hard. That's why we have rigid, stiff bones, okay? Now this thing, canaliculi, boy, this gets real confusing. But basically, in the middle of each of these osteons, I have a blood vessel right here. And there's other stuff. There's lymphatic vessels and stuff like that. But think about this. If I have a cell way out here, let's look at this osteon right here. I have a cell way out here, really far away from the blood vessel. Okay, how do I get nourishment to that bone cell? Well, it's almost impossible because blood can't diffuse straight to that hard bone material. So these canaliculi, see these things right here, they have them labeled here and here, basically are these little canals that allow blood to travel from the central canal, which is where the blood vessels are, to get to the osteocytes and all of those, the osteocytes that are within these lamella in each one of these rings that are surrounding the central canal. It's tough. It's a hard concept to learn, and we will talk more and more about that when we get to the skeletal system. Bone classification, there's really two main types of bone. Really, there's a lot of different types of bone. This is basically the two different ways that bones are made. Okay, there's membrane bones and there's endochondral bones. Membrane bones form through intramembranous ossification. And there's another new term for you. Ossification is the formation of bone. Okay. Think of OS, right? Osteocytes, osteoclast, osteoblast. Now we have ossification, the formation of bone. Intramembranous ossification forms membrane bones. These form within a membrane. Basically, a membrane forms a part of the body, and then a bone is built within inside that membrane, and then that replaces the membrane. So if you've ever felt a newborn's head and it's really, really soft, okay, that's because that newborn's head is basically made of a bunch of membranes. Right now, it hasn't turned, that the skull hasn't formed, okay? But as those bones form, they replace the membrane. And then it turns into hard bone material as the child grows and develops. Endochondral bones, it's called endochondral ossification. These things are going to form through the replacement of cartilage. All right, so you'll actually see a piece of cartilage that looks and is shaped like a bone, but then these bones kind of form from the inside out from this piece of cartilage, which will then create the long bones, such as the humerus. Membrane bones, a great example would be the flat bones of the skull. Great video here, shows you about the development of bone. Take a look at that. I'm not going to play it for you on this video. And I'm going to stop there because this video went a little too long.